Hi, this is your host Apil Bhartiya and welcome to another episode of TFR Insights. And today we have with us Ryan Kwa, Head of Global Sales at CloudCasa by Catalogic. Ryan, it's great to have you on the show.
No, thank you for having me.
There seems to be a misconception that once you move to the cloud takes care of almost everything for you. Of course, high availability and scalability can be expected, but the same cannot be said for things like data protection or security. So, what do you have to say? Just because somebody moved their Kubernetes applications to a public cloud, does that mean they should not worry about things like data protection anymore?
Yeah, definitely. So you're correct. I do think that there is a misconception. There's tons of people moving their data into the cloud, and it does provide high availability. But there's a difference between high availability and high data availability as well. Uptime doesn't translate to the elimination of downtime, right? So when you think about certain things like misconfiguration from a user, maybe they've accidentally deleted a cluster. I was just talking to a prospect last week, and it was an infrastructure manager. They have their stuff on-prem though, but he was telling me how there's some shadow IT going on, and they started dabbling into the Kubernetes space too. And he was doing a data center migration. And long story short, during this migration process, they actually had data loss. And the developer was like, hey, where did my data go? He's like, I didn't even realize you had this stuff, or did you need it to be protected for that matter? Granted, it was only a testbed environment, but still, if that data was being protected, it could have saved them a ton of time from reconfiguring that cluster, bringing it back, and also repopulating that data in regards to the persistent volume. We also see other scenarios as well in regards to things like auditing, where you might be asked to go ahead and bring application configuration back to a specific point in time as well. So I certainly do think, if somebody was leveraging data protection in their environment using something like CloudCasa, it certainly would behoove them.
Thanks for sharing that example. I'm sure there are many customers who have experienced that. Now, when we talk about AWS or public cloud in general, it's a crowded space even for data protection and data recovery. Generally, people look at it as all we need is to restore the data. It's also a sticky market. So, can you tell our viewers how do you differentiate yourself from other players, which may include the cloud provider themselves, incumbent data protection vendors, or even some open source projects?
So I think a couple of things that come into my mind as far as from a differentiation standpoint is, first off, we're a SaaS solution. So from deployment and getting off the ground and running, it's very, very quick. You sign up onto our website, and then you just start registering your clusters and installing it from there, right? And with us, for especially in regards to like EKS, there's inventories, automatic inventories, because we plug into AWS Cloud Foundation as well. And then also bare metal recovery, like that patent I was telling you about. Some people don't really talk about licensing. I think we're very unique from a licensing standpoint too, where all of our competitors out there, they are licensing it on worker nodes versus where we're going from a capacity standpoint, which is certainly beneficial to users in the Kubernetes space.
Excellent. One more thing that I want to talk about is a customer's ability to do cross cluster and cross account restores in the same cloud. Can you talk about some use cases where customers need such capability, or more broadly, why such a capability is needed?
Yeah, absolutely. And I'll give you a real life example. So there's a large pharma company that's leveraging CloudCasa today for that specific reason: cross cluster restore, cross account restore as well. So specific to their environment, they have a production environment, right, with a prod AWS account, and a dev environment with a dev account as well. And what they really needed to do was take that data from prod, move it over to their development for test and dev purposes, right? And we help achieve that. And obviously, when we go through a product demonstration, you'll be able to see that firsthand as well. As far as why do I think they're doing that? I think there's really three main reasons. One being security, in the respect that you probably do not want to give your developers access to the prod environment. Number two is development speed. If you have a developer in your prod environment, they're going to be a little bit hesitant on what they can bring up, what they can bring down. et cetera, as well. So giving them their own playpen, their own environment is crucial. And then from a billing aspect as well, to financially understand where is your money going towards. So that's why you have that different pockets and segregations as well too.
Thanks for sharing those three reasons why people may need it. What about cross cloud restore? I mean, we live in a multi cloud, hybrid cloud world where people run their workloads in different clouds depending on whatever reasons they have. So, how realistic or practical is the cross cloud restore?
Yeah, so I think when we look at Kubernetes environment, and as environments are continuing to scale and to have many more and more and more clusters, you're going to have different cloud providers as well. I think every cloud provider has specific incentives for you to host it over there versus here. From our perspective, we want to be agnostic. At the end of the day, we just want to support where you're going to. You obviously have your benefits and so forth. But as these things continue to scale up and you try to do things manually per se, it is very, very difficult. And I think with our solution, having a central management pane of glass for wherever your environment is, whether it's on-prem or in various areas of the cloud, I think that's certainly key as well. Nobody wants to be locked into a specific vendor anymore. And then I think if you look at from a business continuity standpoint as well, one cloud provider may go down for whatever specific reason. You're going to want to host it at somewhere else. But at the same time, what happens if you're required to protect that data as well? So we can go ahead. We don't really care as long as you register our clusters. We'll be able to go ahead and protect it. And I think, like I said, the specific things, especially unique to EKS, is auto discovery of your clusters, being able to pick up any new clusters that you deploy, apply it to a specific policy, and get that stuff backed up. And then in the event that you ever need to restore, right, you have that bare metal recovery feature, or if you want to restore to a new cluster or something else, or the original one, we give you all of that flexibility as well.
Excellent, Ryan. Thanks for explaining that. Now, we also have Martin Phan, Field CTO of North America, with us, who's going to give us a demo of CloudCasa to literally show us most of what Ryan and I just talked about. Martin, the floor is all yours.
So I just wanted to highlight some of the backup and recovery capabilities that Ryan had referred to about earlier and how easily you can do that and protect your Kubernetes clusters within CloudCasa. So as Ryan mentioned, CloudCasa is a software as a service platform, meaning that all you need is a web browser really, and you can connect to our website at cloudcasa.io. You can sign up for your free CloudCasa account and log in. And once you log in, you're going to see the dashboard here from which you can run all your backup and recovery operations for your Kubernetes clusters or your cloud relational databases. So the first thing that we'll need to do is we're going to need to start and scan in our clusters, and we can do that through the protection tab listed here. So it's very simple. I can just simply add a cluster, let's say an on-prem cluster, by just clicking on add cluster, and I can give my cluster a name. I'll just call it test cluster, for example, and click on the register cluster button below here. Now what it's going to do is it's going to provide me with a kubectl apply statement, a manifest file that I can use to pull down the agent pod for my CloudCasa agent and deploy it into my Kubernetes cluster. So once that agent pod has been deployed, that cluster is going to be able to communicate with my CloudCasa server. Now if you're dealing with cloud relational databases or cloud accounts like an Amazon EKS, you can register that cloud account within the configuration cloud account section. So from here I can add a cloud account, and what this is going to do is it's going to link my Amazon Web Services account to the CloudCasa server so that I'm able to browse and query Amazon relational databases or EKS clusters, basically all the services that CloudCasa would need access to in order to protect it. So you can see here, I have an account already scanned in. That account is active, so I can see the databases listed below here running within RDS, as well as the Amazon EKS clusters that I want to back up and protect or install the CloudCasa agent on. Now you can see that I do have a cluster that I do have the agent installed on already, which is my demo source cluster East. And you can see that it is active currently, meaning that it's able to communicate to the CloudCasa server, and I'm able to back up the cluster and all the resources pertaining to that cluster. So from here, let's go ahead and define a backup job where I'll just jump back to the protection tab, and I will find that demo source cluster East listed here and just click define backup. Now, as I'm defining my backup here, I'll give my backup job a name. Let's call it test backup. And I can also filter the clusters that are visible based off of tags or key value pairs. Now, in this backup set parameter page, what I see is the ability to back up either the full cluster. I can individually select namespaces that I want to back up. So let's say I just want to back up the pods within my website namespace listed here. I can even add the WordPress namespace as well. And I can select those namespaces I want to back up, as well as filter or select based off of labels. Again, we have that key value pair logic where I can use Boolean operators and or to filter down the namespaces I want to back up. I do want to back up persistent volumes in this case. Now, the persistent volumes is what's holding that stateful data for my Kubernetes application. This is the most important part, as Ryan mentioned. We're dealing with environments that can be spun up and brought down within a matter of seconds. And as users move more towards that stateful data environment, they're going to be looking to back up that persistent volume data. So I'm going to select to include that persistent volume data. I do have the ability to enable what's called application hooks. Think of these as pre and post scripts that you can use to coalesce a database or thaw a database to, in other words, put it in and out of backup mode during your backup. The most important part here is this snapshot only and snapshot and copy section, meaning I can just simply take a local snapshot of my persistent volume data, which is going to just invoke a local CSI snapshot or an EBS snapshot, depending on where that persistent volume data is living, or I can perform a snapshot and copy, meaning I can either copy that data to the object storage residing on CloudCasa, or if you want to back it up to your own preferred object storage, you can also scan in or bring your own storage into the CloudCasa portal if you want to. And from here, I can just schedule my backup job, so you can define a schedule for your backup very intuitively, or you can run it ad hoc just by selecting the Run Now button here and defining a retention based off of days. So this is a backup job that I've already defined and run a few times now, and you can see that this backup website job listed here, it has been run several times. The last time it was run was around 11 o'clock this morning. So if I want to restore from any of these snapshots that have been cataloged, I can just click on the Restore button, and it's going to see the snapshots that have been taken locally or have been copied over. I can just simply select the snapshot that I want to perform a restore of, and now select the namespaces that I want to perform that restore. So in this case, I backed up that website namespace. Again, I can filter for individual labels, and I can also specify a level of granularity in terms of resource types. If I just want to restore a deployment or a pod or a secret, for example, I can go ahead and select those objects within my resource types listed here. Now, I do want to restore those persistent volumes. Remember, that's the stateful data that's being captured and copied over to our CloudCasa server. So I'm going to go ahead and include those persistent volumes as well in my restore job. Now, this is where it gets interesting. So as Ryan mentioned, we have multiple ways in which we can restore this data. One is our patented or patent pending cluster BMR restore, in which we can actually create an Amazon EKS cluster for you on the fly while restoring that data. So in this case, we want to, when we create or select our destination, we want to create an EKS cluster, or we can use an existing cluster while performing that restore. So I'm going to go ahead and make things interesting here. I'm going to create an EKS cluster. I'll call this, for example, test restore. And as I'm creating my cluster, let's go ahead and customize my restore by renaming the namespace using my initials as the prefix and, let's say, today's date as the suffix. I can also remap storage classes as well. So if my cluster was using, let's say, a CSI storage class as its source, I can go ahead and remap that to an EBS storage class, which gets created by default from Amazon as I'm setting up my cluster. So in this case, I know that that storage class name is going to be called GP2, and I can remap my CSI storage class to that GP2 storage class name. Now, because I'm creating a cluster, the next step is going to provide me with a wizard that I can use to specify my cluster name. So if let's say I want to call it cluster BMR and today's date. And because I've already scanned in my Amazon account, I can go ahead and use that. And the user that I want to assign this cluster to is my own individual user. So I'll specify my username, and I can specify the region that I want to bring up this cluster in. So US East 1. Select the role that I want to use to perform the operations of creating my cluster. So I have roles that have been created and predefined beforehand, and I'll go ahead and search for those roles and select them. And finally, I can specify a virtual private cloud configuration or a network binding for my cluster when it comes up. In this case, I have the cluster restore job already configured. So as soon as I click save, it's going to kick off my job. But what I want to do is I want to go back and run a predefined restore job that I created previously. So I'll go ahead and select the cluster that I backed up, and you can see the restores listed here. I have a cluster BMR restore that I'll kick off right now, as well as the cross-cluster restore, which again is restoring data to a pre-configured Kubernetes cluster that will also kick off using the same snapshot. So as these are restoring, we can jump back to the dashboard here. We can take a look at exactly what it's doing. So if I look at my cluster BMR, this is my bare metal recovery restore, in which case it's actually creating the cluster for me as it's restoring the application. So I can see that it is going ahead and creating the cluster and waiting for that cluster to become available. And if I jump to my Amazon EKS dashboard, I can just take a look at all the clusters that are available, and I can see my cluster in a creating status. So it's going to take some time for that cluster to spin up. Let's take a look at what's happening with my cross-cluster restore, where I am restoring the application, my EKS cluster, or the namespace within my EKS cluster, to actually a local Kubernetes cluster that I'm running on my desktop. So you can see that it's restoring the resources listed here. And if I jump to my desktop browser or my desktop console, I can just search for the pods that are currently running. And you can see that it is bringing up a data mover to restore the WordPress and website application using my predefined prefix and suffix for those pods that I'm creating. So with that said, I just took you through how easy it is to set up your account and configure a backup and a cluster BMR and cross-cluster restore job. So I'm going to turn it back to you, Ryan Swapnil. Thank you for your time.
Martin, Ryan, thank you so much for taking time out today and talk about how CloudCasa by Catalogic is helping customers in AWS EKS environment. And I would love to have you back on the show. Thank you.
Thank you, Swapnil.
Thank you.